Okay guys, I want to take a look at how to find an inverse algebraically. We're going to start with a pretty easy example and then we'll go on to a more challenging one. The first thing that you need to know are the steps to finding the inverse. So the first thing that we want to do is we want to swap the x's and the y's. So wherever I see a y, I'm going to just place in an x, and wherever I see an x, I'm going to place in a y. And what this does is it's going to allow us to essentially just undo all of the operations, and it will also arrange them in the opposite order of the original function. That's basically what an inverse is. It does the opposite operations in the exact opposite order of the original function. Okay, the only other thing that we need to do is we need to re-isolate for y, so we need to get this y by itself. And I'm just going to do that by regular isolating. So we all know how to do this. I'm going to bring the 5 over. We'll get x minus 5 equals 2y, and then we're going to divide out the 2. And we get y equals x minus 5 over 2. Now normally we would also, if we started in function notation, we would replace this y with function notation. For instance, like f inverse of x equals x minus 5 over 2. Okay, but because we didn't start with that, we can just leave this as y equals x minus 5 over 2. Okay, so there's a couple things before we move on that I want you to notice here. The first thing is that our original function first multiplies by 2, and second adds 5. So the job of our inverse function is to do the exact opposite in the exact opposite order. So this one will first subtract 5, so it does the opposite of the second operation, and then it will divide by 2, okay, which is the opposite of the first operation. So exact opposite operations in the exact opposite order. Okay, so here's a harder example. I'm just going to kind of follow along with the steps. The first thing that we need to do here is, though, in order to kind of follow along with the steps, is we need to replace our function notation with just regular notation. Okay, and then I can see clearly where the y's and the x's are that I need to swap. So remember, the first step is to take all y's and plug in x's, and take all x's and plug in y's. So here we go, x, and I'm going to change this x to a y here. Alright, second step is to re-isolate for y. So I'm going to do this the same way that I always do. I'm going to start with this guy, and I'm going to move him over. Okay, we're going to get x plus 7, and we'll just do this step by step. Okay, I'm going to divide out this 2 here. Okay, so that's now gone. So we have x plus 7 over 2 equals 1/3 y minus 5 squared. Okay, so before I touch anything inside of a square, I need to get that square out of there. Okay, and I do the opposite of squaring by square rooting. And we need to remember that when we square root, we have to account for all possibilities of that square root, which are all positive and negative options. So with that, our square root and our squared cancel out. Okay, so now I'm just left with this guy inside the brackets here, and I can actually drop those outer brackets, which I did right here. Okay, I'm just going to continue moving on to isolating again. Now, a 1/3, in order to get rid of a fraction, I just need to multiply both sides by its reciprocal, which is 3 over 1 in this case, which is really just 3. So I'm going to multiply this by 3, and then I am left with just a y minus 5 on the left side here, and 3 times the square root of x plus 7 over 2. Okay, now the last thing that I want to do is just get this 5 isolated, so I'm going to have 3 times the square root of x plus 7 over 2, and then plus 5 equals 1. Now we're just going to change back into function notation, so the f inverse of this function. And that's our final notation. Okay, don't forget on those square root ones that you put the plus minus. Okay, that's very important.